Welcome to Discovery to Solutions.
I want you to picture a demo 10 PDFs, maybe 20. Someone uploads them, asks the chatbot a question, gets a clean, accurate, well cited answer in 4 seconds. Everyone in the room claps, procurement signs off, budget gets approved, timeline gets announced. And then somebody asks the obvious question 3 months later: why doesn't this work the same way on our actual document repository?
The answer is simple because their actual document repository has 500,000 documents. Inconsistent formatting, scanned PDFs from 2014, sitting next to clean exports from 2025, three different naming conventions, duplicate versions of the same policy with no indication of which one is current. 10 PDFs is a tech demo. 500,000 documents is a data engineering problem wearing an AI costume.
And here's what nobody puts on the slide: naive RAG, the kind you build in a weekend tutorial, fails at retrieval roughly 40% of the time. 40%. Not crashes, not errors. It gives you a confident, well structured answer, grounded in the wrong document. And it looks exactly as polished as the right answer.
Welcome to Discovery to Solutions, where we bring technology conversations from the whiteboard to reality. I'm Kavya Malhotra.
And I'm Karan Khanna.
Today's topic is one we've been circling for 2 episodes now: RAG Retrieval Augmented Generation. We talked about it briefly when we covered AI and data engineering. Today we go deep. Specifically, why the gap between a RAG demo and a RAG system in production is so much bigger than anyone tells you walking into the project.
If your team built something impressive on a sample dataset and is now wondering why the real rollout feels like starting over, this episode explains exactly why and what to do about it.
Let's quantify what actually changes between 10 documents and 500,000. At small scale, almost any retrieval approach works. Your embeddings are distinct enough, your corpus is small enough, that even sloppy chunking finds roughly the right thing. At enterprise scale, every weakness in your pipeline gets amplified. More documents means more near duplicate content competing for the same query. More ambiguity in what relevant even means. More opportunities for two documents to look semantically similar while saying contradictory things.
And it's not just an accuracy problem, it's a cost and infrastructure problem too. Production rack systems are running 3 times over their initial budget, according to multiple field reports this year. Not because anyone did the math wrong, because nobody accounted for vector database synchronization overhead, hidden tokenization costs, and the ongoing DevOps burden of keeping a complex pipeline alive. A demo runs once on a laptop, on data that never changes. Production runs continuously on data that's being added, edited, and deleted every single day.
There's a piece I read that put it perfectly. Your RAG system works on 10,000 documents. Here's why it dies at 30 million. The core insight is that bigger context windows don't save you. Sharper filtering does. People assume if retrieval is a little off, just retrieve more chunks and let the model sort it out. Doesn't work. Research from Chroma tested 18 frontier models: GPT, Claude, Gemini, all of them. And retrieval performance degrades as context length increases, even on simple factual tasks. Dumping 50,000 tokens of retrieved text at the model doesn't make it smarter, it makes it more confused with extra steps.
Okay, so now let's get into the part you actually wanted to talk about: chunking.
Yes, let's move ahead, because this is the single most under-discussed, highest leverage decision in the entire RAG pipeline. Everyone obsesses over which LLM to use: GPT-5 versus Claude versus Gemini, which embedding model, which vector database. Meanwhile, chunking quality constrains retrieval accuracy more than almost any of those choices. There's a clinical decision support study from late 2025. Adaptive chunking, aligned to logical topic boundaries, hit 87% accuracy. Fixed size chunking, same corpus, 13%. That's not a marginal gap. That's the difference between a system that works and one that doesn't.
But it's not as simple as fancier chunking always wins, is it?
No, and this is the part that surprises people. ANAACL research paper in 2025 found that the computational cost of complex AI driven chunking methods often isn't justified. Fixed 200-word chunks matched or beat semantic chunking on plenty of retrieval and generation tasks. And a 2026 benchmark across 50 academic papers found recursive 512 token splitting actually outperformed semantic chunking, which produced fragments so small, averaging just 43 tokens, that they lost too much context to be useful.
So the lesson isn't use the most sophisticated method. It's test the simplest method that could plausibly work on your actual documents before reaching for complexity.
Exactly. My rule of thumb: start with recursive splitting, somewhere around 400 to 500 tokens, with 10 to 20% overlap. Measure your retrieval accuracy. Only move to semantic or hierarchical chunking if you can prove the accuracy gain justifies the extra processing time and embedding cost. If a 3% recall improvement costs you 10 times the compute, that's not a win. That's a vanity metric. And the goal of any chunk, regardless of method, is the same. It should be able to answer a question on its own without needing the surrounding context to make sense.
Now let's talk about the other decision everyone overthinks: the vector database. Pinecone, pgvector, Weaviate, and a few others people bring up. Qdrant, Milvus. Clients come to us with strong opinions about this before they've even defined their use case.
Here's the honest version. pgvector is the right default if you already run PostgreSQL. You get vector search living in the same database as your relational data. Same backups, same access controls, same transactional guarantees. For most teams under 10 million vectors, it's genuinely production grade. Companies running real production traffic, Superbase, Instacart, run it at meaningful scale. The ceiling isn't PG vector itself, it's single node Postgres. Somewhere around 50 million vectors on a well provisioned instance, you start hitting a wall.
Pinecone is the right call when you want zero infrastructure overhead and you're willing to pay a premium for it. No clusters to size, no indexes to tune. It's the fastest path to production for a team without dedicated infrastructure engineers. The trade off is cost at scale and less control. You don't see the index parameters and you can't tune them. If your team has no Postgres expertise and managed everything is a real requirement, Pinecone removes that entire category of problem.
And Weaviate earns its place specifically when hybrid search is the center of your workload. Pure vector search loses on rare tokens, product SKUs, error codes, exact policy numbers. Keyword search still wins those. Weaviate gives you PM25 plus dense vector fusion as a built in feature, not something you assemble yourself. The honest caveat: its schema model and module system add real learning curve. I've seen teams choose it for the hybrid search story and then spend weeks fighting the schema design.
So the actual decision isn't which one is objectively best. It's three questions. 1. Do you already run Postgres and is your scale realistically under 10 million vectors? If yes, start with PG vector. 2. Do you have zero infrastructure capacity and need to be in production fast, regardless of cost? If that's the case, go for Pinecone. And 3. Does your workload genuinely need both keyword precision and semantic search fused together? Then choose Weaviate. Most teams skip the first question entirely and jump straight to comparing benchmarks. That's backwards.
And don't pick based on a 100 million vector benchmark when you have 200,000 documents. That's like buying a cargo ship to cross a swimming pool. Migration between these isn't free, but it's also not the catastrophe people fear. Pick the one that fits today's scale. Reevaluate when you actually outgrow it, not before.
Now, the part of this conversation that conference talks tend to skip entirely. Everyone presents RAG as the solution to hallucination. Ground the model in your own data, and it stops making things up. That's only partially true. And the part that's false is the part that matters most.
There was a controlled study late last year. Researchers ran 12 enterprise RAG implementations. They planted one deliberately misleading document into each knowledge base, a fake policy that looked like it superseded a real one. In 8 out of 12 cases, the RAG system retrieved that fake document and cited it as authoritative because its embedding overlapped strongly with the query, not because it was true, because it sounded relevant.
That's the core problem. Retrieval systems don't have a model of truth. They measure semantic similarity. Does this chunk sound like it's about the same thing as the question? They cannot tell the difference between a correct guideline and a very well written incorrect one, which means RAG doesn't eliminate hallucination, it changes its shape. Instead of the model inventing facts from nowhere, it now confidently cites a real document that happens to be wrong, outdated, or contradicted somewhere else in your corpus.
And here's the one that really should worry people. Even when retrieval is good, even when the system finds the right documents, the model can still fabricate the citation itself. There's a well known example. A RAG powered legal assistant cited a specific contract section requiring 30 days written notice for termination. The trace showed the retriever returned 5 chunks. None of them mentioned that section. The model invented the citation, and a simple pass fail evaluation still scored the answer correct because the final answer happened to match what the user expected to hear. That's a system that looks healthy from the outside, while quietly failing on the inside.
And this is exactly why RAG is dangerous when it's treated as a trust solution instead of a retrieval mechanism. A chatbot that's wrong 10% of the time, but always sounds confident, will erode trust faster than a chatbot that says, I don't know. Because nobody double checks a confident answer. They only double check the answers that sound uncertain. Your riskiest failure mode in enterprise RAG isn't the system that admits it doesn't know. It's the system that's wrong and sounds completely sure of itself.
The mitigation that's actually working in production right now: post hoc citation grounding. Every claim the model makes gets atomically checked against the retrieved chunk it's supposedly citing. If the exact text isn't there, the citation gets rejected, not displayed. Teams running this in healthcare pilots cut fabricated citations by roughly 2/3. It's not perfect, but it converts an invisible failure into a visible one. And visible failures you can catch before a customer does.
And the organizational lesson underneath all of this: don't evaluate your RAG system only on whether the final answer looks right. Evaluate retrieval and generation separately. A correct looking answer can come from bad retrieval and a model that hallucinated, or from perfect retrieval and a model that simply ignored it. If you're only checking the final output, you have no idea which failure you're actually protected against. All right, a CTO calls us. Their team built an impressive RAG demo. Leadership is excited. They want to know what happens between now and production.
First, don't scale the demo. Rebuild the pipeline with production assumptions from day one. That means testing chunking strategy against your actual document mix, not a clean sample set. Your scanned 2014 PDFs and your clean 2025 exports behave completely differently. Second, pick your vector database based on your real scale and infrastructure capacity, not a benchmark chart. Start simple. pgvector if you already have Postgres and reasonable scale. Don't over provision for a future you don't have yet. Third, and this is non negotiable, build retrieval evaluation and citation grounding into the pipeline before launch, not after the first embarrassing incident. If you can't verify that every citation traces back to an actual retrieved chunk, you don't have a production system. You have a confident guess generator with good PR.
And my addition, decide explicitly what your system does when it doesn't know the answer. Most teams never design for this. The model is trained to be helpful. So by default, it guesses. You need to design the I don't know path as carefully as you design the here's the answer path. A system that admits uncertainty preserves trust. A system that's always confident, even when it's wrong, destroys trust the moment someone catches it. And they will catch it. Build the guardrail before you need it, not after the first time someone makes a decision based on a hallucinated citation.
The demo proves the concept works. Production proves whether you actually engineered it. Those are very different achievements. Most teams only budget time for the first one.
So, RAG isn't easy. It's not supposed to be. The architecture is simple to describe and genuinely difficult to operate well at scale. Chunking matters more than model selection. Vector database choice should follow your actual scale, not a benchmark chart. And hallucination doesn't disappear with RAG, it just gets better at hiding.
If your organization is somewhere between impressive demo and nervous about production right now, that's exactly the gap we spend most of our time closing. We've fixed more confidently wrong chatbots than we've built from a blank page.
Next episode, we're tackling a question that comes up in almost every architecture conversation we have. Real-time data, when you actually need it versus when you think you do. If your team has ever demanded real-time dashboards for a metric that genuinely only needs to update once a day, we have some things to say to you.
So see you in the next episode. Thanks for listening to us on Discovery to Solutions.